Hi, I'm Alan. I'm going to present our paper explaining side touch input on mobile phones, finger reachability, and two-dimensional taps and flicks using the index and thumb. This work was finished at the University of Waterloo with Quentin, Adnoni, and Dan. We addressed the issue of mobile touch input, such as occlusion, the finger may block the content on the screen, or due to the limited screen size, GUI widgets have to compete with document of interest. Also, single-handed touch input vocabulary is limited, so researchers are still investigating new forms of phone input. One possible input area is using the side of phones. For interaction, Spelmazen extended power button into supporting 6 gestures. For sensing, Infinite Touch used the one-dimensional capacitive sensors to detect touch input on 3 sides of phone. We combine and extended previous works by studying reachability around sides and investigating a more expressive two-dimensional side input space. Two application demos show the usage of two-dimensional taps and flicks. In the drawing application, a two-dimensional side tap command menu is demonstrated. Flick toward upper or lower edge can open or close the menu. Commands are arranged corresponding to side position and edges. Tap on the different location can select the color and stroke weight of the brush. In the map application, we show how taps and flicks could be combined. Flick along the edge zoom the map in or out. Different edge indicate to different zoom speed. Tapping the upper edge recenters the view to a predefined location. Different position along the edge can be a different city. 3 experiments were conducted. The goal of the first side reachability study is to understand the preference and ability to reach side of the phone. 18 participants were recruited and all 5 fingers were tested. The images show 3 phone mockups and 16 side locations around the phone that we tested. 2 measures were collected in this study. For the preference score, participants rated from 1 to 7. In addition, they can give 0 indicating they cannot reach the location. And we used computer vision method to calculate the grip stability metric from the initial and region grip images. Here shows the side reachability results of preference and grip stability by location and phone size for thumb, index, and the best score across other 3 fingers. As the results show, all locations can be comfortably reached. However, the bottom side is least comfortable and should be used only for infrequent functions. Thumb and index fingers can reach most side locations, especially the middle to top right for the thumb and the top left for the index finger. We then use this area for the following experiments. To make our result accessible to the designers, we created an interactive reachability viewer showing interpolated measures for each finger on any device size between our small and large mockups. Designers can hover to view the scores, select measures, fingers, and phone size to check the corresponding results. Then we conduct a side tapping experiment to investigate thumb and index 2D side tap performance. We asked 12 participants to tap 3 edges and 8 positions with their thumb and index finger. Figures show the test location and experiment interface. We combine the capacity sensing with motion tracking system to simulate touch events on the side of phone. Our pilot test found touching the upper edge with the index finger was difficult, so only the lower edge and the middle are tested for index. Here shows the performance and preference rating of side tapping results. Overall, thumb tapping is more accurate and more preferred than the index. It may due to greater dexterity with the thumb. When using the thumb, the upper and lower edge were more accurate. This is likely due to tactile feedback on the edge. Midway side position were preferred since they were closer to a rest position. When using the index, middle edge was difficult to reach and less comfortable. Therefore, one-dimensional side input may be more suited for the index. The third experiment investigated side flicking gesture with thumb. We tested the flicking gesture. which are short and fast dragging actions. 12 participants were recruited. We asked them to perform the flicking gesture for both types, a long edge and a cross edge, and in both directions, abduction and adduction. For the along edge flicking, 3 edge and 3 positions were tested. And for the across edge flicking, we only test in 3 positions. Here shows the task and the experiment interface. Following figures show the results of side flicking. For along edge flicks, all gestures were rated above nature. However, the bottom locations were rated lower, likely because the thumb needs to be bended to reach bottom positions. For cross edge flicks, abduction flicks have higher score since it's more steady than other direction. We summarize some design recommendations for two-dimensional side input. First, middle to top location are preferred since the bottom part of the device is usually used for grasping. Second, due to the dexterity and familiarity, thumb should always be prioritized. Third, taps are generally faster and more appropriate than flicks. Last, a faceted side shape is better than two-dimensional input due to the edge tactile. We then created a fully two-dimensional side touch sensing prototype to illustrate the potential of side input. It uses the custom PCBs, each with a capacitive sensor to detect a touch event. In conclusion, our work showed that every location around the phone can be comfortably reached, and side touch input can be expanded into two-dimensional taps and flicks. Especially side input with thumb has great potential. Please see the paper for more detail.